and this will be for anybody who is unable to participate, or if you saw something you wanted to review. So welcome everyone. This is our second teacher chat webinar for our online course with Project GUTS. I'm Paige Prescott. I'm here in Santa Fe, New Mexico, and this is sort of the birthplace of Project GUTS, which started as an after-school program to work with middle school students in computer modeling, and due to our partnership and the growth of interest in computer science, we are partnered with code.org to offer the computer science and science curriculum and professional development. And we're just trying to get as many people comfortable with our concepts and ideas to bring it into things like a science class, because we feel that if computer science is going to be fundamental, that it can't just be an elective class, that it should be in, something that all kids are exposed to. And if a content area like science is a required middle school course, then, it'll just get infused in that way. And same thing with computer science and algebra. So we want to get as many kids exposed to this. And so that's why we are embedding it into our science curriculum, and it is aligned with the NGSS. And even if your district or state is not adopting NGSS, it still is going to inform a lot of other resources in general. And I think it's a pretty good structure for informing our science education, the NGSS that is. And then, we're just also hitting a lot of the CSTA, Computer Science and Teachers Association standards, as well as ISTE, and just all sorts of skills are layered, I feel, in our curriculum, because it's not just about the content of learning what an ecosystem is. It's like, how would you model that? What are the frameworks, the ideas, the abstractions that go into that? And then they also have to think about code, so what is a forever? What is a repeat? What do conditional statements do in computer science? And so those are the other things that students learn and walk away with. So let's see. Module 1 is the foundational one. It's Intro to Computer Modeling and Simulation. And this assumes no prior knowledge of kids and teachers. So it's the first day, or the first lesson, I should say, is the walk and turn activity. And this one is the foundational one to kind of get bridge between an kinesthetic experience of doing the walk and turn, which is, turn to your neighbor, adjust and take a step towards them. And if kids do it right, they end up in kind of a weird spiral, which is actually an unexpected feature. The kids do not expect that for the most part. And then you take that to looking at walk and turn on a computer, and can have a really rich conversation about why we do computer modeling in general. Why is it a scientific tool? Things like, these are experiences that are too slow to run without a computer, or they're unethical. Like, for instance, epidemiology, you wouldn't want to just release a disease and see who gets it or not. So, these are reasons to do computer modeling and why they're important to science. And that walk and turn is the conversation and experience that allows kids to connect to that information. And so they don't look at code for that first lesson at all. They're just thinking about computer modeling. And it's really lesson 2 that they look at Star Logo Nova. Probably the hardest part of Star Logo Nova as a teacher would be to get all the kids registered and create a login. And that requires, thinking about what are the protocols that kids already know about creating logins and passwords, and to just build on that. Star Logo Nova is hosted at MIT. They do not collect any kind of data, so it's not, needed to get extra parental permissions or anything like that. So whatever your district or school policies are in terms of computer use, Star Logo Nova falls underneath that. And I just recommend that whatever the school does or is already in place for students in terms of login, just repeat that, and also keep like the password simple. It could just be password, or it's the same password that they use for other things. Because again, it's not really sensitive stuff, so having secure passwords are not necessarily the most important thing for this. But it is tricky to get set up. And then you do the flower turtle, and they just are hooked from then on. So yeah, why it spiraled, I'll come back to that. So we have the lesson 2, which is the flower turtle, is really just experiencing the difference between world tabs and the I'm going to open up the world tab and the turtle tab, and where does action go, etc. So I'm going to open up Starloganova and go through a little bit of that. And then I'm going to share my screen so you can see what I'm doing. So let's go back to walk and turn. Yeah, it's the fact that they're moving towards their old, the person to their right or left old position, not following exactly in their footsteps. So moving towards their old position of adjusting their foot to be where that person is now and then walking towards it. But then that person moves, and so it's actually a dynamic kind of configuration, and that's what causes the spiraling, is that either not following exactly their footprints, they're going towards where they were and adjusting, going towards where they were and adjusting. And it just is, I like to always ask kids to predict what do you think will happen. And then also the debrief is like, compare this to the computer model and like what's the difference. And kids will ultimately talk about how they just don't follow the rules, that their things are, their foot size is different or their step sizes are different, and they're not really ultimately very good turtles when it comes to computer modeling. All right, so I'm going to share my screen real quick. And again, I encourage you to put questions or comments into the chat. Or if you want to jump in and interrupt me, you're welcome to as well. I think you're all unmuted, and so you should be able to jump in, and it's up to you to mute or unmute as you see fit. All right, so we're going to share the screen. And I'm in the Starloganova. And this is, when you click on the word My Profile, this is what you come to. And you have this My Classes function is not usable at this time, so don't expect to see that. But you can, you have your private gallery. All your projects end up in your private gallery, and at this time you cannot delete from them. And then this is the Create New Project. Galleries are a great way for you to start to organize your models, especially when you're going to use them with students. And I do recommend that you consider how you're renaming things. So I'm in this new account that I created called Guts.Student, and I don't have much in here, and whatever I have is terribly named. So I have an untitled like project. What the heck is that? I don't even know. And so these titles are not they're not going to be helpful in the future. So I do recommend that you think about titling them to be useful for you, because they are searchable in this white bar. Let's see. When we create a new project, for our purposes, we always use a blank project. And the first-person action game has like a basic paintball model, but we use blank projects. Kids will find that, by the way. They'll figure it out pretty quickly. And so here we are in our, we have the information up here with a timestamp and a date. And this is where you can change the title. This is where you can retype in here. Just a note that your backspace doesn't work in this area here, so you would just highlight what you want to type over and do that. And then here we have all projects start with a setup, a forever, and a score box. Those are widgets, but they are not, there's no code behind them. So if you don't want the score box there, like I'm not going to use that, you can edit widgets and you can trash that. You go to the red area and you can delete that and it's gone. If you want, you can change the name of something. And you can and then this is also how when you're in edit widgets, you can move widgets around and reorganize them. So that's a choice for you. So this is Spaceland, green Spaceland. It is dynamic. You can move in and out. If your mouse is only like zooming, especially with trackpads, this can be a challenge that this is kind of zooming in and out, that you really want to scroll up and down. Click in a white area here, either above or below Spaceland, and then your mouse will work normally. Your trackpad will work normally. But that's one thing, is that this is dynamic for like zooming in and out. But if you don't want that with your trackpad, just click in a white area and you'll be able to scroll with your mouse up and down on the page. So here, all projects start with the world, everyone, and turtle tabs, and these are the spaces for the world. I like to think of as sort of the place where the action starts. So this is the, sorry, not action starts. This is where if you're doing a play, for instance, these are all the characters that get into position. They have their costumes on. They are ready to perform. And that's what's happened in the world. And typically, you're going to have your setup will go only in the world. Turtle is where actions will happen related to that breed called turtle. And so that typically will follow under with a forever toggle. And then the code goes in through here. And so whenever this button called Forever Run, I just renamed it Forever Run, if that's toggled on, all the action, the code that's inside will go on and on and on over and over again until this is turned off. And what else? So those are some things that to look for. Typical mistakes would be that this setup is actually in turtle, or that you think you're coding the movements for turtle here. You know, I'm going to do a wiggle with a, forward or something, and your movement doesn't work. Well, that might be because it's in the wrong location. So if I had a wiggle procedure here, wiggle is typically coded like that. Well, you could create your turtles, but they're not going to move. And that's because this is in the wrong location. So you could cut this and then click on the turtle and you could paste it. And then you could, and it would run now. So save, run code, set up world, and then forever. So they're moving around. We can zoom in. One thing I showed people last week is that this is actually, you can go into 3D if you use your Alt key and your mouse, and you can zoom. You can create the 3D view, so you're looking horizontally at the Spaceland. All right, so you can see that they're actually gray cubes when they are started. And if you get lost, if your spaceland disappears, you can always hit reset, reset camera. All right. I'm going to check the chat and see what's happening, and see if there's any questions so far. So, a couple false start projects. Yeah, you can't delete them from your private gallery, but you could create a new gallery called Module 1 or online course and then organize them into that gallery. But if they're currently, any project that you start is going to end up in your, starts in your private gallery, and at this time you can't delete it from there. So, the everyone page is an area that, so we could have code here that all breeds would be able to use. So currently we are really only working with one breed called turtle. We could create another breed called, let's see, and when we go down, we can see that there's now a new tab there. Now let's say I create some of these new second breeds, right? And I'm going to show them to be a different color. Set my color to cyan, right? So save, run code, they're created. I should and I should always start with a delete everyone. So good coding practice for Starlogo Nova would be to always have a delete everyone first and a clear terrain. It doesn't matter what order those go in, but that just kind of resets everything. So let's put this, so I'm going to set up. And so I have two different agents, one's gray, one's blue. It doesn't really look very different, so I'm going to make it red. And so now we have two, and I'm going to hit the forever. Remember, we could have the others. And so this second breed doesn't move.
We don't see your screen.
Oh, what's that?
We don't see your screen.
Oh, because I'm still in my, I didn't share. I'm so sorry.
That's okay.
Bad webinar techniques. Okay, so let me go into this. All right, so what I did was I was in the world and I created a second breed. So you probably didn't see that, did you? So why don't I make another one? So I can go into edit breeds. I can add a breed. This will be my third breed. You can name it whatever you want. And once I do that, you can see that there is now another tab there for that. So this is, I'm going to eventually answer this everyone question here, but just showing you some functionality of Starlogo Nova. So now I'm going to create some agents that are our new third breed. And I'll create 20 of the third breed, and I will give them some a color as well. And I will set that color to yellow, maybe. Okay. Save and run code, and so we should see three different breeds. So we have the yellow, we have the red, and the original grayish white. And when I hit the forever, the only ones that are moving are the original turtles. And that's because the procedure for movement is only here in this turtle tab. However, if I put this in the everyone, then you'll see a difference. And we will save and run code, set up our world, and then now everyone is moving. So the everyone code is available to all breeds. So if you put something in there, for instance, if you make a trait that's an everyone trait, or some sort of procedure that is made in everyone, then all breeds are accessible to that. Or typically, the way that we set up our curriculum is that we don't use the Everyone tab at this introductory stage, and we have everyone make the movement for turtles, the movement for their second breed, the movement for their third breed, and that's mainly to practice the coding experience. And then, yeah, so that's sort of a philosophy of why we do that. I'm going to check the chat really quickly and see if there's a question I should. Where did I go to create that new breed? It's up in the Spaceland area. So am I sharing? Yeah. Okay. In the Spaceland area, there is this Edit Breed button, and when you click it, you can add a breed down below. And if you didn't like the name of the breed, you can rename something, or you can delete it if you don't like it. Edit traits is something that we also can introduce in Epidemic. You can add a trait called, let's say, and this is something that we do in ecosystems, actually. You can see this. You can make a trait, name it like, let's just say new trait. And these are used very similarly to things like, well, I call them, for right or for wrong reasons, like with if you're true to computer science, they're kind of like variables in some ways. But there's this trait drawer here, and you can see in the Set My, there's a drop-down menu of things. And so all of them originally have an X, a Y, a Z, a heading, a color, a shape, and size. And you can see that that new trait, I created that, and that's now in the drop-down choices. And so you could do things in ecosystems, you'll see it as energy. So within the trophic levels, how does energy move through the trophic levels? And so that's one of the things that is highlighted in that curriculum. So we can trash that. And so those are just a couple things, quick overview of how to create a breed, what everyone does, and sort of the difference between, again, the world is who are the agents and where are they in Spaceland, and then the other tabs are more about the action. All right. So I wanted to go over some things with just extensions to some of the projects. And so we have the flower turtles, and flower turtles is a fun one it just engages kids in these to learn how proper sort of introductory ways of engaging in Starlogonova, and they just end up making a flower, but they can really add different layers to it with colors and things like that. And we did some challenges, and here's, you can create 5, and then you can have them try drawing. So this looks pretty complicated because I've added new setups on there and everything, but you can have them make triangular petals. Or I can create 5 turtles and make them, and they have square petals. And so this engages them to think about the math that's involved and the angles of the turtles. They could make hexagon flowers, right? And so these are just changing the angles that they turn. Or I could have a set of turtles in the middle circle and a set of turtles on the outside, and they can make these beautiful patterns. And so kids can get really deep into this, and sort of, if you had time, kids can go in this direction. All right. So that's one of the extensions for flower turtle. Another extension that we have is called painted turtles. And painted turtles is really just about exploring the beginnings of what's called wiggle walk. And I'm going to remix this. So this is the painting turtles. I'm remixing the painting turtles what is that called? Base model, starter model. And so this is basically a flower turtle's extension. So we have the world and some blocks that we need. So again, the best is to always reset. So these two blocks reset things to the green spaceland, and we want to create some turtles and scatter them. And in this case, we're going to do some random colors. And in the turtle, we would have the forever, and 10 down is you can either have in the forever or the seventh, it doesn't matter. But then we're going to add some movement, and instead of prescribed forward 1 and then left by an exact number of degrees, we're going to add some randomness in here. And this set right here is called the forward 1, left by a random number, right by random number. This gives us the what we call a wiggle walk, and this is really common in agent-based modeling, is to do the wiggle walk. So it gives each of the agents this randomness. They're not going to all have the same exact movement patterns. So we set up, we have them scattered around, and then when we hit forever, you can see that they have a little bit of movement there. They're not exactly straight line, and so that's typical of our of agents in like a, you know, for instance, the chemistry, they're not all going to be moving, the molecules don't move in straight lines. In ecosystems, you know, rabbits are not always going to be exactly moving in a straight line. And random 10 is a little bit small. You could increase that. Let's say I went to random 90, and you can see a difference. We could also make a slider for this as well. And so now you're seeing a big difference in terms of their actual patterns that they're making and thinking about the wiggle. So what's happening here is that each agent moves forward 1 and then left by 0 to 89 degrees. And then from that position, it'll move right 0 to 89 degrees. So the average is going to be straight. It's going to be just a straight line, but this is giving it some dynamic qualities to it, and you get to see these crazy patterns. I'm going to check and see if we have any questions right now. And, oh, randomness. The range of randomness is if you put in random 100, your range is going to be from 0, the computer would pick a number between 0 and 99. All right. This pattern here, or sorry, the wiggle walk is also something that is talked about in Dyson data, and creating sort of, and then that is activity that leads into colliding turtles. So that's lesson 4. Activity 1 is Dyson data. And they, using DICE, they kind of explore this idea of wiggle walk, and then they can apply it to their project. Now, they could do this as a flower turtle extension as well, and they kind of get this idea, and then they understand it mathematically in the activity called Dyson data. Let's see if I can answer that. Correct. So there's a random factor of degree. So in this case, it's really, we can use random in lots of different applications, and in this case, we're just using this random to choose a direction. So if you're a turtle and you are only going to walk forward 1, like this code is, you're going to be in a very, very straight line. But what's happening here in this code, the wiggle walk, the left by and the right by, it doesn't matter which one's first, by the way. They both can end up with the similar outcome. But the agent's going to turn from their original heading right by 0 to 99 degrees. So it's going to be random what that actual degree is. And then it's going to, from that new position, new heading, it'll go a little bit to the left between 0 and 89 degrees here. And again, that's just adjusting the heading. Ooh, look at our patterns there. That's just adjusting like sort of their direction of that movement, and this is to, let's see, it's in contrast to, there's a trait called heading here, or you could do step my, there we go, step my heading, and you could also, so heading is based on basically the cardinal directions, like, or a protractor. So 0 heads your agent in a certain specific direction on spaceland. And this is basically between 360 degrees. So heading 0 degrees is to the right, 90 is up to the top of spaceland, 180 is to the far left, and 270 is going down. That's covered in our Module 2 water resources, and you can learn more about the math basics. All right, let me see if I can, oops, that's wrong. Okay, so we have some questions. Good. Thank you for the help there. So I'd like to move on to thinking about lesson 3 of our introductory module. And this starts with the activity called Trailblazers, which is basically they're creating a maze to pick up all the fun, the gold, and then they're avoiding certain traps. And that's a hands-on paper and pencil kind of project. And then they're learning to code that in their using Star Logo Nova. So again, from Flower Turtle, which is kind of just learning the like 6 or 7 new blocks, now they're going to, in lesson 3 with Bumper Turtles, they're going to remix the project. And so I'm going to do that here. And so students would take a project that already has some code and then remix it into their own. And you'll notice that there's already some code here called paint landmarks. And there's the setup and the forever. And in the world, if you take a look, the paint landmarks is there, and kids are not supposed to change that. They're only supposed to change what's happening here in the turtle, and this is where they're thinking of conditional statements. So so it would read something like this: if the terrain color that they're on is equal to the color red, so if the terrain is, they're on a red patch, what should they do? And in this case, using the same logic from the Trailblazers hands-on like paper and pencil experience, they do a right by 90. And they're going to need this for the 3 colors, red, blue, and black. So I'm going to highlight this code here. I know already that I need it 3 times, so I'm going to copy it and paste it. And by the way, whenever you paste something, it always ends in the upper right of the spaceland. And so you just have to grab it there. So the logic statements are going to be, the turtle is going to move forward 1. If it comes to a red patch, it's going to turn right. If it comes to a blue patch, it's going to turn left. We need to change that movement. And if that's 90 degrees. And if it gets to a black patch, or if it's on a black patch, it's going to turn around completely. And in this case, it's called 180. And that could be a left or a right. You get the same outcome. So we're going to take a look, save, run code, and we have our paint landmarks we're going to set up, and we have those 4 agents in the middle. Each of them is facing a different direction, so they should hit different patches. And we saw there that some of them reacted to a red, Now, sometimes they could be created and there's no patch in their way, so they end up just looking like a straight line. In that case, you would just do paint landmarks again and see if we get anything. So notice that this one, this agent here is probably going to move and not have anything to react to. But we already know 2 of these have had things in their pathway and they've reacted to them. We can always speed things up with this speed slider. It goes to the bottom is to increase the speed. Or if we want to see it go slower, we can raise that bar up. So some extensions, if kids move through this quickly and you wanted to have, the accelerated or fast-moving kids do something, well, they could, instead of turning right, they could maybe change their shape. So it could have a different kind of reaction that happens when they hit that color. Or they could try changing the size of their agent to start with. So maybe I just do 2 here. And I'm going to see what that looks like here. So we'll repaint our landmarks and we'll set up and see how they're bigger, and we'll move them forward. And if they hit a red one, I'm going to speed this up. If they hit a red one, they should turn. Oh yeah, we saw that. This guy changed into a giraffe. So we have 2 giraffes. Now we have 3 giraffes, and they're tiny, but they're there. You see those little giraffes? Yeah. And notice that these that agent just went through the other agent. They don't have any coded awareness. They don't know what the other agent should be doing at that time, so that's what happens in lesson 4 is learning about detection, which is colliding turtles. All right. So we're going to zoom out, and so that logic, this conditional statement that the students were kind of exploring here, becomes really important for a lot of the other stuff that they'll do in Epidemics and then the other modules. I'm going to pause here and see if there are any questions, anything that I should be addressing. So there's some good chatting. Irene, thanks for your help on this. Irene is our guru, the one who started Project Guts, and that was back in 2007. And we are now almost in our 9th year, almost the 10th year, and she's now in Massachusetts. So we are bi-coastal, I guess, or all over North America with our facilitators and people that have been helping us with our projects and programs. All right, so I'm going to move on now. So that was lesson 3 with bumper turtles. Lesson 4 goes into Dyson data, and it is the Dyson data is the one where they explore wiggle walk using probability, and then it will see. All right, good. The lesson, it ends, the coding lesson is applying the wiggle walk in the colliding turtles, and then also learning a new block called collision. So you would have students remix this one. And the instructions are in this, the description up here, what they're supposed to do. And basically, the colliding turtle is a blank project, so there's really nothing in it. So we want to have them practice doing a setup and a forever again. And so practice, where do things go in the world? Where do things go in the turtle tab? And I think I started this, so let me call it mine. And so this one, you would, in the world, you have the setup. And so you have, in my case, I did 50 turtles that are orange and that they're bigger, and 10 turtles that are the color cyan and also size 3, and then they're scattered at the end. And what that should look like, this, where we have the orange and the cyan colored turtles, and they're just bigger than they have been in the past. And for the turtle, what we want to do is have them move. So we talked about the wiggle before, and I just want to show you, I made a procedure here called wiggle. Procedures are gotten from this drawer here, and you can rename. Sometimes you have to double or click or triple click to change the name of something. And hit enter at the end of that, and then you'll see that this call is going to be needed. So in the forever, it's going to loop through that over and over again with each tick, and it's going to call this procedure, and it's going to use this code from top down, and then it's going to call this this one. And if I put code in here, I'm not going to put new code in there, so I'm going to get rid of that stuff. But that's our wiggle walk, is sort of the forward, the left by a random amount of degrees, the right by a random amount of degrees. And so they move in just kind of, you've seen this before, just moving around the surface. And they're bumping through each other, but they don't have the computer science, like they haven't been coded to be aware of the other agents. And that's what we're going to do here with the collision block for lesson 4, and we use this on collision with. I got it from the detection drawer, and so this is the creating awareness for other agents. And so when a turtle, so I read it like this. All right, so we have a drop-down menu, turtle. When a turtle collides with a turtle, what do you want it to do? And then that code goes in here. And so it could start off with something really simple, just like that it changes its color to, let's say, yellow. And we should see eventually that they just start to change. So it doesn't matter what turtle they bump into another turtle, which means that they share the same patch, that they will change color. We have 2 left over. All right. So let me check if there's spreading cooties. All right, cool. So let me go back to that. The extensions for this, so this quickly just gets remixed into the epidemic model, which is lesson 5. So basically all of the skill sets end to culminate with creating an epidemic model. And they already have the basics here already. But what we want to think about for a true epidemic model, what would make this more realistic? So right now, as a turtle moves around, they will, they just get that, in this, we could call it a disease, right? The yellow disease. And but any agent can spread it. But that's not true typically with disease scenarios. So what we want to think about is we're going to have some initially sick turtles, and they are going to spread a disease, and we represent that disease with a color. And then we're going to see how fast does it take for that disease to spread through the community. And then we can add other features like recovery rate to that and transmission rate. What I like to do with this is, so we have a nice collision, like it's working, we know that's working. So I remixed the colliding turtle one and have the students then build on the colliding turtles to create their new epidemic. So again, naming conventions. And we could and that'll help me to remind myself. And then I always do recommend at the very beginning of a new project that they add it to their public gallery, because then when they share the URL with you, it's automatically done. So this is a nice sort of start to all new projects, is to name it, give it a description, and then put it to their public gallery. Like, that's a very good way for students to always do that, always start a new project. So now we're in lesson 5 with the epidemics, and we already have something that basically works, but I wanted to show you how to make a slider real quick. A slider is a widget, and we want to make a horizontal slider. And I like to just play around with population to start with. Population. And so we can add that widget, but see how that's covered up there, so we can be in Edit Breeze and we can move that so that it is visible. We're not using score right now, so I'm going to get rid of that. That's actually a data box, by the way. So we're going to have this. And remember, when you make any new slider and you want to change these numbers on the minimum and the maximum, this is, you have to, with the maximum, let's say I'm going to make it up to 500. Oh, maybe for sick, I'll just make it up to 50. And whatever number you put here, you must put enter or return in order for that number to be accepted. And so now you can see it starts with 0 and it goes all the way up to 50. And it has sensitivity down to the thousandth, which we don't need, but it just is there. You can change that by clicking on this this gray bar here, and you'll get the slider properties that you can change. But how do we implement this? We created that slider, and you want to get out of Edit Widget, and now we can go to the world, and I'm going to pretend that, let's see, healthy. We'll make my 100, I'll start off with 100 healthy turtles, and they're going to be size 2, and they're pink and healthy. And the sick turtles will be, yeah, I'll leave them as blue. And instead of creating 10, I want it to be dynamic to the population. And so I can go to Interface and grab a block called Slider Value. And I can put it here. Notice it has the same shape as a number, and it will fit in there. And you have to select which slider. And in this case, we only have one called Population Sick. And we can start that off. So what does that look like? We'll save it. We'll run the code. And we'll hit Setup. And so that was at the maximum. What if I have it at the very minimum setup? Notice that the 6 blue ones disappeared, or in this case, they were not created because it was 0. But let's say I just want to start off with a small population of 10. And every time you move the slider, you do not have to hit Run Code, all right? It just will. So what if I want 50% to set up this? So that's something that allows us as science teachers to start engaging students with thinking about how to run experiments, because these sliders naturally lend themselves to independent variables, and that's true with the transmission rate and the recovery rate. I'm going to pause right now. We have 10 minutes left. See if there are any questions. Open it up to you guys. Anything I can help you with? I'm going to stop sharing my screen. We doing okay? Was that too fast? If it was too fast, yeah, I could see some nods. Then, this will be available later tonight if you wanted to review any of those. It's also skills that are discretely covered in the different videos there. And, again, we're trying to be responsive to the forums. If you have technical difficulties or something that's happening in Module 1, just pop it in there. Make sure that your project is shared to public so that we can, if you're going to share your project, like, what's going on? Why isn't this working? We can take a look at the code really quickly and give you some suggestions on that. But for the portfolio is an area where we're just asking all of this to kind of get populated into the Google Site portfolio. And this is a way to just kind of keep track of where you are and if there are any gaps or anything like that that are happening. So right now we just finished sort of the introductory Module 1 simulation. There's a lot. This is a really rich, there's a lot going on in this module because it's so foundational. But then when students and yourselves move into either the Earth, Life, or Physical Science modules later on, it'll just, lots of the information will click in a different way because you're not going to be creating models from scratch. You're going to be remixing things that already exist and you're going to be modifying them. So we do a progression in our curriculum called Use, Modify, Create. And so starting off with using something, like using an ecosystem or a chemical reactions model that already exists, then remix it, modify it, make some changes, and then after you're comfortable with that, maybe go on to create something that's your own unique project. Or you just end at modify. But either way, there's a lot of rich learning that's happening for students because they're not only learning the science, but they're also learning the coding and thinking about computer modeling and just lots of different kinds of learning come out of that. Let's see. All right. So should I continue and finish with Epidemic, or is there anything else we want to talk about? No? Well, let me go back to Epidemic and we can just finish up with transmission and recovery rate. I will tell you this, there's some interesting things that happen with the epidemic, and there's a subtle difference between transmission rate and recovery rate. And recovery rate slider, the way that we tell you to code it, is a very sensitive slider, and so the quote-unquote disease dies out pretty quickly, and I'll show you why that is. So I'm going to share my screen again, and but interrupt me if there's anything that I should hear or know about, and we'll finish in about just a few minutes. So I'm back in my new epidemic model, and I have a population slider. And here we are in turtle, and they're moving around, and when they hit another turtle, they automatically turn. But I want them to test, first of all, so I'm representing sick by the color cyan, and so I want them to test and see if there is a sick agent. If they collide with a turtle, they're going to check to see whether it's sick or not. And so we do that with logic. And when I know already that my equals is also in logic, and we're going to use some traits. If the blank, if the color of, so we're using color to represent the disease. If the color of, and in this case we have to use detection, which is the collidey. So if this turtle bumps into another turtle, it's going to check, are you the color of, are you sick? And they're going to check to see the color, if it's cyan. And if you are, then I'm going to get sick too. And so they become cyan as well, right? And so we're going to save this, run code, set up. And so we should see that it's not going to go quite as fast. The spread of the disease is not going to go quite as fast. But it is, in this case, the way it's coded is 100% transmission rate. So no matter what, if they hit a blue thick turtle, they're going to, a cyan colored turtle, they're going to get sick. And so we want to add another layer in there about what we call transmission rate. And we use a slider to do that. So I'm going to add a new slider. We're going to call it transmission. And again, we have to move it out of the way. And when we think about transmission rates, it's like a chance that it's going to get fixed. So I want to base it on 100. So you hit 100. Remember, hit enter, must hit enter. And we can see that it goes all the way up to 100 and as low as 0. And now we're going to use that code in what's considered nested logic. So we're going to test, not only are we going to test that they're sick, but we're also going to have a chance that they, based on the transmission rate, get sick. And so this one, we set up basically an equation. If the number, and use random, and we're going to then use the slider value. Remember, we now have 2 sliders, so we're going to use the transmission rate. So the way that this is going to read is it's going to test to see if they if they collide or come in contact with a sick cyan agent. And if so, they're going to do this equation. If this random number, so 0 to 100, is less than the transmission rate slider, then it's going to, and it fits that parameter, it'll get sick. And so this is basically a chance based on 100%. That's why we have a random 100. And then we can, it'll dynamically, you can move this around. So if it's a very virulent disease, it would go up to 100, and as low as, you know, something like 1 or 2%. So we're going to save that, run code. I see that we're running out of time, so we're going to finish up with this. So forever, and it's at a very, very low transmission rate. And so we wouldn't see the disease spread very fast, but we could put it here and we would see it go a lot faster. Again, we're having that discussion with students about the science of it. Now, recovery rate is going to go inside, it's going to have its own procedure, and it's going to go inside this forever. And it is going to look like it just is, it's going, that the recovery rate, because it's in this forever loop, it's going to go over and over again. It's going to go through every tick. The turtle is going to test whether it fits that recovery rate procedure or not. Whereas this collision, whereas transmission rate only happens if they collide with the turtle. And so it's, you'll see a difference with the sensitivity of those sliders, transmission rate versus recovery rate. And if you have any questions about that, just post that into the forum, and I'll try and answer that as best as I can. So we're going to finish up, and I just want to say thanks for sharing some part of your Sunday, and thanks for being part of the course. We're really wanting to get as many people involved in bringing computer science and computer modeling to their students, and you're part of that. So this is a, part of something that's spreading across, we could make an agent-based model of this. And we just want to hope and encourage you to continue with your own knowledge in bringing coding into the classroom and how to create computer models. And then for those of you that are going to train others, how to train people with that. So thanks very much. Appreciate it. Be in touch with any questions or any suggestions and all that good stuff. All right. Thank you.
Thank you.
See you in cyberspace.